So before we actually start with today's session, I would like to quickly recap what did we discuss yesterday for 5 minutes, and then we'll go with next exercise. Okay. So what was the exercise that we have done in the last session?
Convolution.
Convolution operation, right? So what was the input that you have taken for working on with convolution? Okay, you have taken a matrix. Okay, assuming that it is a image thing. Okay, so but we really don't understand how padding actually works when we deal with the matrix data. Hence today we'll perform the same convolution on an image. Okay, we will not take a matrix. We will take a image and see how convolution works on image. Okay, before that, when I talk about convolution operation, why do we use convolution operation? What is the main purpose of convolution operation?
To detect the important areas, the curves.
To extract the features of the data, to extract the features of the input image, or to detect the patterns in the given data, we go for convolution operation. Hence, today in the exercise, we will take a image, give that as input, okay, apply a filter of some n by n size onto that image and see the result after convolution operation. Okay, we'll see how the images are convoluted and how do we extract the features from that particular image. Okay, but before we go to the session, I'll quickly recap what did we see. Okay, so we already have ANNs, which are generally called as what? Fully connected networks. Okay, so we have two important drawbacks for which ANNs will not work mainly for images. What are they?
Loss of spatial data.
Loss of information, that is spatial features, and the second one,
Increased
high computational cost because of more number of neurons that we have to consider when we take a image. Okay, why do I say more number of neurons? Because depending upon the size of the image, I calculate row into height into the dimensions of that particular image. So those many number of neurons has to be calculated in the input layer, in the hidden layers, and then weights also has to be calculated for n number of neurons. So this increases the computation cost, hence we don't prefer ANN working on with images, for which we have the next structure, which is what? CNNs. Okay. So drawbacks of ANN for image classification: too much computation, treats local pixels same as pixels far apart, that is local invariance is not available when we go for ANN dealing with images, and then sensitive to location of an object in an image. Okay. Hence we have seen convolution neural networks are the best architectures that are used basically for working on with images. Okay. Now this is the simple, the second figure actually represents your convolutional neural network, which has series of layers or series of operations that takes place before we actually give it to a fully connected network. Okay. So what are those different layers that we have seen? One is pooling, one is convolution, and the other one is what? Fully connected layer. What do we do first? We do convolution operation, and the main purpose of convolution operation is to extract the important features from the image. Next we do pooling. Why do we do pooling? Pooling is used for reducing the size of the image or reducing the dimensions of the image. These two are the major drawbacks, right? The size of the image and then losing the information when we divide 2D image into 1D vector. So that is overcome by convolution layers and pooling layers. Okay. So today in the session we will take an image and apply convolution on the image and also pooling on the image. What do you mean by pooling again?
reducing the size of the
Pooling is used for reducing the size. But what do you mean by pooling?
max pooling.
We have two types of pooling, max pooling and average pooling. What do you mean by max pooling?
Takes the maximum value of the matrix.
Take a range of pixel areas into the image and take the maximum value of it. What is average pooling? Average of those pixel values, right? So we have seen this example. So when we operate the image with convolution layer and pooling layer, what will happen? Despite of the features present in different locations, your convolution operations will be able to detect the important features, as we have seen the example of column in the last class. Similarly, we have seen example of 6. Okay, so this is the architecture of CNN. First we have input layer, convolution layer, we apply activation functions on the convolution layer, and then we give it to pooling, and then the output of the pooling will be given to fully connected layer for prediction. Okay, so if your result is not as per this thing, what will we do? we'll again go for backward propagation with optimize. Here also we have forward propagation, loss function calculation and backward propagation. The only two things which are different is before we actually convert the image into 2D, we perform these two important operations which are called as convolution and pooling. Okay. Yeah. So how many convolutions, how many poolings you do, that depends upon the suppose I have, yesterday we have seen one image of so many buildings in a picture, right? So if you find the image to be so deep to understand, we go for more number of convolution layers and pooling layers. In the example of digit 9 or koala image, okay, digit 9 is very simple than koala, right? For digit 9 we go for only one convolution, one pooling. For koala image we may go for 2 layers. Okay, that depends on the complexity of the image that we actually work on. Okay, so these are the layers that these are the steps that we work on when we deal with images. What are they? Input layer, convolution layer, apply active. Why do we apply activation function again? To introduce non-linearity, to make other values as 0. Okay, we have taken ReLU activation function here to make other values as 0 and put only the positive values which actually has the information. Okay, after that we apply pooling and then give that to fully connected layer and extract the output. Okay, so we have seen what convolution does. What does convolution do? What is convolution operation? On the 5 by 5 image or n by n size image, what do? We apply a filter of m by m, and then what do? We go for element wise multiplication. Summation of the element wise multiplication would be given to new output destination, which is called as feature map. What is it called as? Feature map. So here the source layer would be the image on which we will apply the convolution kernel or the filter, and the destination layer would be the feature map, which is nothing but the element wise multiplication of the filter applied onto the image. Okay, so we have seen how do we do this. Okay, so what do you mean by striding? Skipping, moving the filter from one location of the image to another location. If I say stride is equal to 1, what does that mean? One location, one column location would be moved. Okay, so here what is the stride? You can look at the first picture on the left, step 1. I have 1 0 minus 1 and 0 boxes covered. Okay, in the next step I am covering 0 0 minus 2 and 1, that is I am just moving one column location, and hence I say stride is equal to 1. Okay, yeah, this is striding. Okay, there are 3 important parameters that we have to consider when we do convolution. What are they? Image size, stride, padding. Why do we use image size? Is what? The size of the image that we do. Striding is done for moving the kernel from one location to other on the image. Why do we do padding?
To detect the edges of the image.
To detect the edges of the image. Today we'll clearly see what will happen on the image. Of course, on the matrix you'll not understand how do we detect the images and all that edges. But today in the exercise we will be working on taking an image as input, apply convolution with padding and see what is the result. Apply it without padding and see how the edges are detected with padding. So do you all understand why do we use padding? To extract, to take into account the information on the edges of the images such that nothing will be lost, because sometimes in few images the important information may be available on the edges as well. Like we have seen in the last class, 9 may be written on the top left or bottom down where the edges are covered. Okay. So these are the parameters: filter size, stride and padding. Okay. So why do we use filters? Filters, applying filters is nothing but the convolution operation which is actually used for detecting the features in the images. Okay. Next, activation function. Why do we use activation function again? To introduce non-linearity where only the pixel areas which has information would be activated and rest of them would be made 0. As you can see, the first is the image, the second is the filter that I am applying, the green one. Third figure is the feature map that I have extracted by element wise multiplication of the kernel on the image, and when I apply activation function ReLU onto that feature map, I extract a new feature map. Is that clear, everybody? Okay. So next is what? The feature map extracted here would be given to pooling. Okay, we have 2 types of pooling, max pooling and average pooling. Okay. So why do we use pooling actually? Pooling is used to reduce the size. Okay. Now you can see on the feature map which has extracted the information. When I apply pooling, I have applied max pooling. The result would be like that. Okay. The size of the image, the dimensions of the image are gradually reduced. We will also see pooling operation today in the class exercise. Okay. We'll give an image and see how the size of the image is reduced when we apply pooling. Okay. So we'll see how convolution extracts the features from the image by covering padding operation and seeing how the edges information are being highlighted, and we will also apply pooling and see how the dimensions of the original images are gradually reduced. Is that clear, everybody? Okay, so what are the benefits of pooling? It reduces the dimension of the image, hence reduces the computational cost, reducing overfitting, and also reducing local invariant problem. Okay, and then we give that to fully connected dense layer with which the classification operation happens. Today we will not go into classification or the fully connected layer. We will end with working on convolution operation on an image and see how pooling affects, see, stride and pooling are the hyperparameters that we give, right? You give stride 1, 2, 3, 4 and observe the changes. Once we are done with the exercise, I'll ask you what is happening when stride is 1, what is happening when stride is 2, what is happening when stride is 3, what will happen when you go for 0 padding, no padding. Is that clear? So this is what you have to tell me once you're done with the exercise. So what are the two operations that we are going to do, two exercises that we are going to do today? Convolution operation on the image, pooling operation on the image. Okay. So luckily it's your luck that we cannot give test cases for images. I cannot give test case for image. Okay. So it will be a practice exercise only. Okay. But we will be checking who has done, who has not done. We'll call you and I'll ask you what is the result when stride is 1, when stride is 2 and all that. Is that clear? So we'll on those exercises. We'll end that previous exercise wherein we have taken a matrix. Okay, today we will take image and do it. Okay, so I'll quickly explain you how do we read the image and work on that. After that you can start working on the exercise. Okay, so what is our exercise for today? First exercise, 3 by 3 convolution on 5 by 5 image with and without padding. Here we are taking which data? Image data. Okay, one 5 by 5 or some n by n size image and apply a filter on that. Okay, so there are few important libraries which you have to consider when you deal with images. Okay, so the first library is PIL. Okay, so from PIL we have to import what? Image. Okay, because we are dealing with image today in the session. From PIL you import what? Image. Import numpy as np, import matplotlib as pyplot. Please do practice underscore image underscore convolution. The exercise name is practice underscore image underscore convolution. Please open that exercise. Refresh your dashboard. Okay. So first step is import libraries. That is already there. Okay. Yeah. Okay. Next we'll see how do we import the, see here I have taken cat image, but you can download any of the images that is available in your laptop. Okay. That is okay. Otherwise you can download your own image also. Okay. So you can upload one image. You can see one plus column in your dashboard. Okay. You can add one image onto that. Okay. On the left where you see image convolution, you can just click not there. Okay. You can just click upload. Okay, you take the cat image only. Okay, you take that cat image that is given as input. Okay, yeah. First try to load the image. We'll give you the image, don't worry. I don't think student version has upload option. Okay, so what did I do here? I have taken a variable called image underscore path where I've given the image name. Okay, so the image that I've taken was JPEG image with the name IMG. So I've given that. And then I am trying to open that particular image using the image which we have imported from PIL library. Okay. So I say image dot open, give the image path, dot convert into lower L. See, do I need color image for extracting the features? Is there that need that I want color image for extracting the features? Even if it is black and white or color, I'll do. Okay, I can extract the features. But why did I convert the image into grayscale here? because the size of the black and white image would be less compared to the color image. Here my main intention is to extract the features even if it is black and white or color. So to reduce the complexity of operations, I have converted my image into grayscale. Okay, for doing that you just have to do dot convert L. Okay, now convert the image into a numpy array. Why do I do this? Why do I have to convert the image into numpy array? Because the computer will understand. I've already told you how a computer reads an image. Okay, so even if you take an image as input, the computer will read that as an array with pixel values. Give image underscore path is equal to give that path. Don't write img.jpg. Give the path of the image. Okay, and then say image dot open. Don't give the path in the second line. Image underscore path దగ్గర don't give that. That is already the variable that I am taking on the top. Give the path only in place of img.jpg. Don't give that path in the second line. Okay, in the second line image path is nothing but the variable in which I am giving the path. Okay, it was my mistake. Did you all finish this? JPEG. Got it? Did you all finish this? Finished? Image underscore path is equal to give the path name and rest of that it is same. Okay? To process color image, you can simply remove that dot convert. You can process that color image but it takes more time. Okay? Yeah. Now we'll see the image. Okay? Display the image. For displaying, what do? I just use the function imshow, image show. Okay? plt dot image show. Okay? plt dot image show and see CMap is equal to gray. I've already converted that into grayscale. So this is one attribute which we give for seeing the grayscale image. And then say title. You give some title for that image. I don't want to see x-axis, y-axis because I'm not bothered about the points here because it is not a matrix data. So I'm just offing that plotting axis. Then give plt.show. I'm using simple matplotlib to view the image, to display the image. Finish displaying the original image. Okay. Now what do we do next for convolution operation? We have to define a kernel, that is a filter. Okay, please do that using np.array. Using np.array, define a kernel. So this is just a practice exercise. In the next session on Saturday, you have to build a complete convolution neural network, CNN, which covers convolution, pooling and then fully connected also. Okay. Define 3x3 kernel. Create a 3x3 kernel filter or kernel matrix. Okay. Now define the convolution function. That you have to do by yourself. We have done that in the last session. Same thing. Define convolution function. Okay. Define. I'll just explain you. Quickly recap. So define a function called convol in which you have to pass 3 parameters: image, kernel and padding. First you have to add padding and then you have to give the dimensions of the image and the kernel. After giving the dimensions, you have to calculate the output dimensions and then apply the loop wherein you will perform the convolution operation. Please do that. Define convolution function. After filter, don't sit like that. Though I am not displaying it, you have to do the next part of the code. Define convolution operation. 6 steps that you have to perform for convolution. First, add padding to the image, give the dimensions of the image and kernel, calculate the output dimensions, initialize the output matrix and then perform convolution operation. We'll give you 10 minutes to complete convolution. After that, for the next half an hour, we'll be working on pooling. Do you find any difference with padding, without padding? Not much difference though, but you can see some difference. Okay, what is the difference now? What is the difference between the original image and the image after convolution with padding and without padding? You tell me the two differences. Image, original image convoluted with padding, original image convoluted without padding. Yes? Edges are covered, okay, because you are including padding, okay. Without padding, yes, okay. So the major focus would be on the features, important features of the image, okay. The other sides of the image would be blurred. Only the image which has important features would be extracted. Did you finish? The one in pink sweater. Did you all get this? So what is the difference between the original image and this image? In my image, I have so many things covered, but the main thing is I want to extract the features of the person who is taking the photograph. Okay, so the edges are highlighted and only the important part of the image is being displayed. This is without padding. What do you mean by without padding? The corners of the image are not highlighted, that is they are left behind like that, such that I may lose some important information. See, though I don't have any important information in this particular image as example, but we may have some information, okay. So when you look into this, observe the borders, okay, the borders are also highlighted, that is the features inside the borders are also highlighted with convolution operation when you include padding, okay. Change the size of padding and check padding 1, 2, 3, 4 and observe the differences. Padding is equal to 1, not much difference. 2, 3, 4. Don't go for 6, 7 padding again. That covers the entire image. Okay. So this is how the original image is displayed. And after I apply convolution without padding, the borders are not highlighted, only the important features of the image are extracted. And when you apply with the padding, you can also see some information related to the borders are also taken into consideration. This is all about convolution operation and how do we apply that on a image matrix and a image. Okay. So I'll give you a couple of minutes. Please close this. We'll off that exercise and we'll switch on to pooling operation. Okay, I'll give you 5 more minutes. Please complete this. All those who have done the previous exercise, please open the next exercise. The name of the exercise is image practice underscore image underscore max pooling is the exercise. Please open that exercise. Practice underscore image underscore max pooling. You can do average pooling and check the difference. You can also apply max pooling on the image and check the difference. Please complete the convolution operation. We'll switch on to the next one, pooling. Okay, now let's see convolution pooling operation as well. So the first step is you have to import libraries. Okay, here I am importing NumPy. To operate on images, you can also use PIL, and there is another library called CV, Computer Vision, which can also read images, CV2. Okay, so to explain you that, I have taken different library here. You can also use PIL. From PIL, you can also import image, or you can also use import CV2. Okay, so I have imported NumPy as NP, import CV2, import matplotlib.pyplot as PLT. Okay, so once you are done, see, before we actually import libraries, you have to first of all install OpenCV. Okay, so pip install OpenCV is what you have to do first. Run that block of code. Before we actually import libraries, add one more cell on the top. Add one more cell and type pip install OpenCV. Pip install OpenCV -python -headless. You have to import pip install library to pip install for accessing OpenCV. Import NumPy, import CV2 and then import matplotlib.pyplot as PLT. Okay, first pip install CV2 and then OpenCV and then import the libraries. After I do this, you have to take image as input and pre-process it. What do you mean by pre-processing? I am converting the color image into grayscale image. Okay. After you import the libraries, perform some image pre-processing. Define a function called process underscore image. Give the path of the image that we have given. Read the image and say cv2 dot imread underscore grayscale. Try reading the image and do some pre-processing applying grayscale on that image. If you don't want to apply grayscale, you can also read the color image as it is. There are different steps again when we talk about image pre-processing, which we will discuss later in the coming sessions. Image augmentation, okay, image flipping, image rotating, okay, turning image ups and down, considering only one part of the image. All this comes under image pre-processing operations, which are not required here for now. We'll discuss them later when it is required. Import the libraries, before which you have to pip install OpenCV library. Read the image and pre-process that image. Read the image, pre-process that image. And after this, implement max pooling. See, for this image data, we can't create the test cases, hence we didn't do, but we'll learn the exercise on max pooling, which is graded 1. Yeah, I'll just explain you how did we do max pooling. Yeah. So once you take the image or once you read the image and pre-process it, we have to apply max pooling on that. Okay. So I have defined a function called max pooling in which I pass the parameters matrix, the size of the image, and then pool size. What do you mean by pool size? On the image, the size of pooling, the number of boxes that I have to take for operating the for performing the pooling operation. So here I want to go for 2 by 2 size pooling. Okay. And then stride is equal to 2. We have seen what is striding. Okay. Why did I take stride is equal to 2 here? Because when I am going for pooling, I don't want overlapping. Once I complete one section, I have to go for another section. So when I say 2 by 2 of pool size, then I have to go for stride is equal to 3. If I take pool size of 3 by 3, I should take stride is equal to 3. Because once I am done with those 3, I have to go for the next 3. Got it? So please you have to remember this. Okay. So initially my pooled matrix is what? An empty list. After I perform pooling operation, I will upload my pooled data into this particular matrix. Okay. So for I in range of starting from 0 with respect to matrix shape, I will apply stride on the rows. Initially I have put row as 0. Now for j in range, I will apply append operation and I use the function np.max. The max value on that particular 4 columns that I take or 4 boxes that I take, I apply that and I use that onto the emptied matrix, pooled matrix. Okay. Simply take a pool size, apply that onto a original image, and then original image is nothing but the feature map, and then find the maximum value by using np.max. Okay. What does that I colon I plus pool underscore size equal to 0 represents? I and j. What are I and j? The row and column. First row, first column. First row, second column. Second row, first column. Second row, second column. So in this way, when I talk about 2 by 2 matrix, I'll have 2 rows, 2 columns. I represents the rows, j represents column. So 4 positions. I and j as 1 and 1, 1 and 2, 2 and 1, 2 and 2. So in this way, I'll complete the 2 by 2 matrix. Okay. So this is implementing max pooling. After that, you can also implement average pooling. What did I do in average pooling here? Instead of np.max, I use the function np.me. That's all. The remaining thing would be same. Display the function to original image. Okay, first I'll display my original image and then image with mean average pooling, image with max pooling. Okay. Is this part of the code open? Yeah. Okay. So this is how we implement pooling. As there is no test case for this, we will on another exercise where you have to take a image of some matrix like what we have done on Monday session for an image. Take a pooling image size and then apply pooling onto the image. Okay. What is that exercise name? Okay, there's an exercise with the name max average pooling. Okay, that is a graded exercise. We want you to complete that today. See, this is only for practice. You keep this aside. Get on to the next exercise, which is max underscore average underscore pooling. Work on that. That is a graded one which will not be repeated again. We have 20 minutes now. Please complete max pooling and average pooling on the graded exercise. Close this image one. This is only for your understanding. Complete the exercise max underscore average underscore pooling, not with the image. You have to create a matrix. We also have given you the values that you have to take in the matrix. Please take that matrix, take a pool size and then apply pooling, both average and max. Those who are done with the exercise can leave.